Okay, so we have game time. We're doing a quick and fast game. And it's a online version of the Guess Who. So for each statement that we will get, you have to think for your own and answer with a true or false. Is this true or this is false for myself? Okay? If the answer is true, you can continue playing and answer the other statements. But the answer is false, you have to turn off your camera and game is over for you. Okay? So are you ready? Thumbs up? Who's left? Awesome. So you made it to a lot of variables. What do you think will be the next step for you to continue playing? All the participants were a code. So you were a variable. A variable is a concept that it's like a container of experiences and information and all these statements. So each of you area is a unique variable. So you were giving a true or false statement according to your own taste or life. And we had these rules to play. So in order that you, the ones that were left, keep playing, we had to add more values and more information. So you are really, really unique. So when we are coding and designing and all of these things that we are doing, it's really good to think that each one of us is different and our solutions and the things we are doing will be different for each of one of us.
What we've been doing here is each week, we've been trying to sort of build you up a little bit from maybe being completely a novice with the microbit to trying to add in some layers of a little bit of code here and there and some understanding of what sensors and capabilities it has. And so this week and next week, we're going to go a bit further before we sort of open the doors and say, okay, we haven't taught you everything, of course, but what is it that you want to do? What types of projects do you want to do? And then we'll work with you to try to help make those happen. And so in this case, we just want to sort of say that this week, what we'll be talking about is just like Barbara was doing. We'll talk about variables a little bit, logic a little bit more, and then we'll add in one output that we think is pretty cool, which is a servo, which we'll show you what that is when we get there. But again, this helps to sort of build up your understanding of some of the code and maybe allows you to do some more complex things. We usually frame each week with sort of a design issue. And this week's design issue is one that would allow us to use both some of the stuff that we've done before, but then also this idea of a servo. And we'll explain again what that is in a minute. But situating it within COVID, right? The idea is that you might be bored and you want to do something with the microbit that can, help you teach your pet a new trick. And so the problem that we're going to think about this week and eventually your challenge will be, how can you create something that can use this servo mechanism to dispense a treat or to help dispense a treat, whether it's candy or a dog biscuit or something for your cat or whatever, in a way where you can use the microbit to do that.
Okay, so let's talk about I'm going to zip through these next two slides pretty quickly. We're going to talk about two really important things when we're writing a computer program. The first one being variables, which Barbara has already told us a little bit about. So these are things that are containers that are going to store different bits of data into your program. This data that you store in there can be a bunch of different types of data. It could be words, it could be numbers, it could be true and false kinds of things. So a variable can store lots of different bits and pieces of data in there that we can call back in other parts of our program, and it can trigger different kinds of events. These variables will have a name and they'll have some kind of value. In some instances, that value might just be a string of characters that you're using. Okay, and then, so that's a real basic. We're going to go through a kind of live coding session here in just a second, where we'll really dig into variables and the logic in a little bit more depth. But I at least want to talk about the basics of these first. So we'll jump to logic next. And logic, I like to think of sort of analogies. A lot of times when I'm trying to write a computer program or an algorithm or anything else, I have a tendency to do it in the sense of being a story. So I'm trying to tell a story. There's a concept of kind of writing pseudocode that you'll learn about, and maybe we'll talk more about in a different session. Pseudocode is basically if I write out what I want my program to do, but I don't use computer code to do it. I just use my natural language, right? So later on, what we're going to do is we're going to write a short computer program. And when I do that, I'm going to sort of speak out the pseudocode that I'm going to try to use to make my program function. So pseudocode is just a way of expressing it in natural language, okay? The logic is really what you're trying to get at with that pseudocode, right? You're trying to figure out how am I going to structure this thing so that it will make sense. So I think of the logic in a program as the way that a computer is going to think through the problem that I want to solve, okay? So that's what the logic is. You saw on Barbara's slide earlier this idea of conditionals, okay? There are conditional statements, and some of you used some conditional last week when you used either if statements or while statements. So while the temperature is this, then do this, right? So the basic structure of logic that we're going to start with today is an if, then, and else, okay? And the example that I would give you, kind of, again, with that storytelling idea, with the pseudocode sort of idea, is that if I am deciding what I'm going to wear, I want to look at what the weather is going to be like to make that decision. So that would be my condition for what I'm going to wear outside. So if it is snowing, right, there's my if statement. If it's snowing, then I'm going to wear boots, okay? Else, I'm going to wear shoes, okay? So that's at the basic level. That's the decision that I'm going to make. I'm going to look out the window. Is it snowing? If it's snowing, this is my logic. If it's snowing, then boots. If not, sneakers, okay? All right, then we're also going to add in here, when I get into the live coding session, this other idea, which is the else if, okay? And you'll see that in action. I want you to raise your hand if you have ever played rock, paper, scissors. So let's think about rock, paper, scissors from a pseudocode perspective. If I want the computer to play rock, paper, scissors, the way that I play rock, paper, scissors, there's not a whole lot of strategy to rock, paper, scissors, right? I'm either going to select one of those three options, okay? So in terms of a computer, I would say that's a randomized variable, right? The hand that I show, either rock, paper, or scissors, is a randomized variable. My hand is a randomized variable, has 3 different values, okay? So I can create randomness for those 3 things and just have the computer select one of those things at random, okay? So that essentially walks us through the pseudocode, the logic of the program that we need to write. We know that we have to do a little bit of math to decide on a random thing, right? And then we have to create a variable, okay? Those are the main things that we have to do. Right now, I just have the on, start, and forever, and you do not need to necessarily code with me. It's really just more as a demonstration so that you can see how these things will work sort of in practice. Right now, I've got on, start, and forever, and I'm going to get rid of those. For my input, I am going to use an on shake. You could do it on an A button press, a B button press. You could do it whatever input you wanted to, but I'm going to use the on shake button. Okay, so I know now that's going to be my input. The next thing, if you remember back to that pseudocode, was I said I needed a variable, right? And I'm going to call that variable my hand, because I need the hand to carry 3 values of a rock, a paper, and a scissor. Okay, so I'm going to make a variable, and I'm going to call it my hand. Now I've got all of my options that I can use for that, okay? I'm going to go away from that for just a second, okay? Because the next thing that you remember that I said I needed to do was I needed to create a way for there to be a randomization, okay? So what that's going to be is that's going to be just a little bit of math, okay? Because what I want it to do is I want it to pick a random number, which is in math. So I'm going to pull that over and just put it in my window because I know that's how I want it to happen, okay? I'm going to go back to, nope, not my logic. Going to go back to my variables, and I'm going to say, set the hand to, okay? So now I'm establishing that on the shake, I'm going to set a hand to a value, and that value is going to be a random number, and I'm going to put in here from 0 to 2. Now, like if you were looking at that and kind of not necessarily thinking like a computer, you might just think that there are only 2 numbers there, 1 and 2. But the way that a computer sees that is they see that as 3. Okay, because there's 3 options. There's 0, there's 1, and there's 2. Okay, so that's why I set it to be 0 and 2. Okay, now we get into the really interesting part where we have the computer start to make some decisions or to think. So we're going to get into logic now. Whoop. So we're going to say if true then. Okay, but we don't want to know, true is what they call a Boolean, so there's only 2 options, true or false, okay? We don't want that, okay? What we want is we want if our hand, which remember we've randomized, is equal to 0. So far what we've got is a shake input, and then this little bit of math that says set the hand to pick a random number from 0 to 2. Next is if that hand is equal to 0, we want it to give us an output. That output, in this case, I'm going to make a rock, which I'm going to represent like this, okay? All right. The next thing that we're going to do is down here, this little plus sign, we're going to say that just gives me an else. This gives me an else if, okay? because I've got 3 potential options, I need that else if statement in there. Else if 1, then do this. So what I can do is I can hover over this block of code and I can just duplicate that. And then I can just drop it in there because it fits into that shape, okay? So if my hand is equal to 1, you can probably guess what's gonna happen next. I'm gonna take an output and I'm gonna create a representation of a piece of paper, which I am going to represent. My computer is super laggy. I'm gonna represent my paper just like that. Now, the last thing that I'm going to do is I've now said if the hand picks a random 0, I'm going to be a rock. If it picks a 1, I'm going to be paper. Now the only thing I have left, I don't have to roll again because there's only 1 option left. So I don't need to apply that math again this time. All I need to do is create my scissors. And I'm going to do that like this. So that's going to be my scissors. So now I've written my code that's on shake, set a hand to pick a random variable from 0 to 2. If the hand that is drawn is a 0, fill that in with a rock. Else if the hand is 1, make it paper. And then any other alternative, you're going to be a scissors. So let's go over and test our code and see if it works. Oh, sorry, forgot to shake. So I got a rock, I got scissors. I'm gonna keep shaking because I wanna make sure all of the things show up. So you can see that it's just randomly scrolling between each of the potential options of rock, paper, scissors. This structure is one that we're going to come back to again later on today. Okay, so remember, kind of commit that bit of structure to memory so that you'll know when we come back to these different games that we're going to do, you'll have that to do as well.
What a servo is a tiny device. This servo it can move, right? I'm just moving it very slowly right now. But I'm pushing a button on the microbit to get the dial to move a certain number of degrees. I think I have it moving 5 degrees, depending on which button I push. And so the idea is that we're now taking an input with the microbit and producing an output. And that output is more actionable. So, right, so rather than just showing a picture, it's making something move. And so if we go back to the screen, it's powered. So it has 3 different cables, 2 for power and then 1 to get the signal. And that signal tells it where it's going to move to, okay? Because it rotates, and different servos do different things, but most of the ones you'll find sort of rotate in a full 360-degree range. Again, it can be used in a couple different things, primarily in robotics or simple machines. And then it's good to know that at least for the servos, the way that the microbit has it set up, a value of 0. So when we send 0 to the servo, it will be pointing to your left. 90 will be pointing straight down. 180 will be pointing to the right. And then 270 will be pointing straight up. Right? So if you think of it as a full 360 circle. So similarly, I'm going to show you a quick code here, and I'll show you the blocks first. So just very quickly, I created a variable. Not sure why. Maybe I was hungry, but yo tengo hambre. I created the variable cookies, and on start I set that cookies to 0. Usually with variables, particularly with ones like temperature that you might be using, you want to sort of start them at 0 or start them at a starting value. So I set it to 0. And then next thing down is I have 3 button pushes as the inputs that are going to change the variable we just created. So right now we have 0 cookies. If I push A, the cookies go up by 1. If I hit button B, the cookies go up by 5. And if I hit A and B, it sort of resets it back to 0. And then in the forever block, right, it's pretty simple. I have show number, and then this is where it's pretty cool, right? I used cookies as the variable. So I drop cookies in there, and it will show the value of where cookies is at any point in time, how many cookies we have. And then this block here is the key at the bottom. Servo write pin P0 to cookies. And then I multiplied it by 10 because it's, you know, a 1 out of a 360-degree change isn't that much. So you would barely see it. But if I multiply each change by 10, then that change should be more noticeable. So if we go to the simulator here, if I hit A, right, it's changing the cookies value on the screen by 1 at a time. And down here, it is changing the servo, the motion, it was 5 times 10, so 50 degrees around. All right, if we go up to 90, I told you 90 was straight down. So if we go up to 9 on this, basically straight down. And then if we want to jump by 5s, I can get the servo to jump, you know, a higher amount of degrees. So this is the code again. Let me just quickly show you. I think you know where the on start and the forever and all those are. The only one that I didn't show you, or that you maybe haven't experienced before, is the servo one. And that one is listed under pins. The little sensors on the bottom of the microbit are called pins. And in electronics, they're called pins because you'll sort of do pin out and pin in, which is basically sending messages out and sending messages in. And so if we go to pins, a couple different ways we can do this. We're not going to get into all of this right now. But down at the bottom of this first screen, there's a servo write pin, and I'm going to drag that out. And that's what I used. But what I did is I replaced this 180 over here on the right side of the screen with cookies. And so you can, that's where you can add in variables, you can add in some math functions, and it allows you to make changes to those values. And you can do some very, very dynamic things there. Like I did, I multiplied it by 10. You could take absolute value. You can do a whole range of things there that could be interesting. Okay, so so that is servos. What I'd like to do is quickly here have you try to jump in and see if you can create a variable and have change the position of the servo. The challenge for this week is a simple idea, but not an easy challenge, which is how can you use the microbit to dispense a treat, dispense a piece of candy or something like that. So there's going to be an input that a person, an animal, something uses. And then the idea is to get the microbit to interpret that input and then produce an output, but using the servo. So creating motion based on the input and the rest of the code that you have.